Okay. In this video I'm going to talk about proteins. So what are proteins? Proteins are defined as natural polymer molecules that consist of monomers called amino acids. So you realize that proteins are just polymers that are made of a monomer called amino acids. So I hope you understand what is a polymer and what is a monomer. A monomer is just something that the monomers are more like building blocks. When you put them together, they form what they call polymer. So in this case, we're talking of amino acid being put together to form what is called what we are calling proteins. So we'll talk about the structure of amino acids. Amino acids, they look like this. This is the structure of amino acid, which is a monomer of a protein. They've got R group there, they've got H, they've got carboxyl group here. So this is a structure of amino acid. So this is a monomer of which when you keep on adding this, it will give you what they call a protein. So proteins are made of the addition of the amino acid, which is called polymerization of amino acid. So in this case, we talk about the characteristics of this monomer, which is called amino. This is amino acids. This is amino acid. So we'll talk about its characteristics, and so you can see that the amino acid has got the carboxyl group this side. This is the carboxyl group. This is a carboxyl group, and then so that's a carboxyl group. They've got the characteristics of an acid, and then this one, this is called an R group. An R group, this is where the addition of where we have put R here. You know, amino acid can contain a lot of carbon atoms. So if you want to keep on adding more carbon atoms, they'll be added on this R. So you remove the R, you see another carbon there, you add another carbon, and another carbon, just like that. But the basic structure, this is the basic structure. And then this far end, I've got what you call amide group. This is called amide group. They've got the characteristics of a base. The base. So one of the characteristics or the properties of amino acid is that they are amphoterics. They are amphoteric. Just write it down. Amphoteric. This means that they are neutral. They've got a pH of 7. They can eat. They have got the ability to gain electrons and the ability to lose electrons. They are neutral because they fall on each side. If you look at the structure of a pH scale, you find that the other side, this side, which is the carboxyl group, it will fall into the acid group, and then this amino acid, it will fall to the basic group. So it's just on the middle there. It's just on the middle. So that's why it's called the amphoteric, because it's neutral. It can either be to the acid group or basic group. Number 2, we could talk of it acts as a buffer. So what does this mean? It means that a buffer, it has got power to resist the change. It has got the power to resist the change in the pH scale by trying to maintain its natural state. Let me just repeat that one again. It has got power to resist the change in the pH scale by maintaining its neutral state, because it has got the ability to donate or to lose electrons. Okay. Another thing that I can talk about as property of amino acid is solubility. So in solubility, you find that the solubility of amino acids they depend on the R group, this part here. So the longer the chain it is, the more solubility it is. So you find that some amino acids, they are hydrophobic, some are hydrophilic, depending on the size of the R group. Okay, I think that's what I can talk about about the properties of amino acid. So we can talk about the polymerization of amino acid. What do I mean by polymerization? Polymerization, I mean the adding of amino acids. So I've got amino acid here. This is my amino acid, and this side has got a carboxyl group. So I've got this one amino acid. I'm going to add it to another amino acid. Then I've got another amino acid here. And I've got other group near H. Then I've got a carboxyl there. So I see. So I've got two amino acids here. So I've got two amino acids there, if you can check. So I find that these two, they will react through the condensation process and they'll form water. So what I've done is, this is the polymerization, the reaction of the two monomers, and so this, they will give me a polymer which is called a protein, which looks like this. Which will look like this. This is the result of. So you have to know these structures, so that in case you are told to illustrate how the polypeptide is made. Sorry, this is gone. Let me just restart. It will look like this. Then I've got another HN. This is the carboxyl. So if they are supposed to have a OH, but since it has been reacted with another hydrogen which was this side, so I want to put it there. So here I will remain with one H. I was supposed to have another H here, another hydrogen here, but it's because they have reacted, so they are no longer there. Then C to continue to give me C. Then to give me the carboxyl group at the end here. So this bond here, this bond here, it's called a peptide. This bond which joins that joins the two amino acid, it's called a peptide bond. A peptide bond. So this is a peptide bond. When you look here, so if I remove these two, what will remain here? It's what you call a peptide bond. So this is a peptide bond, and so this is the protein that will be formed from there. So maybe you can be asked, by which process does the hydrogen and the hydroxy of the hydrocarbon make? They are formed by a process called condensation. So you have to know this structure. It's called the peptide. So if you have got a long chain, if you are adding more hydrocarbon, more amino acid, so that chain to be called a polypeptide. Why? Because there are a lot of peptide that will be formed. We have another peptide here. So here, if I was to continue to add another amino acid, I was going to have another peptide bond formed here. Then now, so if it's a long chain, it's called now a polypeptide, because poly means more than one. Then from here we can talk of the structures of proteins. Structures. So from that structures, we have got basically 4 structures of a protein. There's primary structure, and we have got secondary structure. Then we've got tertiary structure. Then we've got quaternary structure. The video that I'm making just so brief, so if you want some more, you can just go and research on your own, but I'll just define them. I want to do their structures, how they look like. I'll just define them so that we save time. So primary structure is defined as a sequence. It's just a sequence of amino acid. So I don't know if I can write. It's just a unique sequence. The unique sequence of amino acid in a polypeptide. Just a unique sequence. Let me just write it down. It is the unique sequence. Unique sequence of amino acid. In a polypeptide chain. In a polypeptide chain. In a peptide chain. So you find that it's just the sequence, or the order of the amino acid, the way they are arranged in a peptide chain. That's what they call a primary structure. So you find that maybe in our lectures, right, that we've been drawn how it looks like, but I want to do that one. I'll just define them. And then there's a secondary structure. The secondary structure, it's just the deal of interaction of backbone. I don't know. This is just the due to structure, due to interaction rather, due to interaction, don't have to write it, due to interaction of backbones of amino acid in the polypeptide chain. Just because of space here, but I'll just I'm sure you're going to be able to write. You'll be able to write. So this is just the due of interaction of a backbone of amino acid in the polypeptide chain. That's a secondary. And the examples of secondary chain. So the example of secondary structure, they are alpha-telic structure, and not this one. It's called the beta preheat, something like that. Yeah, I'm sure you will say some more on that one. Yeah, and then the third one is called tertiary. Okay, before I talk about tertiary, let me just clarify the point that I raised in secondary structure. In secondary structure, the examples that are there is alpha ilex, and the beta pleased sheet. Those are the examples. In the slides, I think there are some structures there. There are some examples on how they look like or something like that. But what is important is just to know their definitions and the examples, unless you are told to draw something. And then we're going to talk about tertiary. Tertiary structure is just due to the interaction of the side chain of amino acid in the polypeptide chain. I'm saying this is the interaction. It's the interaction, how they interact. Interaction of a side chain of amino acids in a polypeptide chain. In a polypeptide chain. I'm sure what I'm writing is not so clear, but I'm sure you can write it from what I'm trying to explain. It's just an interaction of side chain of amino acid in a polypeptide chain. That's tertiary. And then quaternary, because usually quaternary or something. Quaternary structure is just the arrangement of multiple or many amino acids in a polypeptide. The arrangement of multiple, meaning there are a lot of them. So it's just the arrangement of multiple peptide. Let me just write it down. Just about the arrangement, or the arrangement of multiple amino acids in a polypeptide chain. So that's basically the structures about proteins. And the other thing that we can talk about is the denaturing. So you find that these proteins, they can be denatured. So denation, it's just basically the loss of the specific three-dimensional shape of a protein molecule. I repeat, it's the loss of a specific three-dimensional shapes of a protein molecule. So protein, when they get destroyed, they even lose their shape. So the changing of the shape there, so that we are calling the denation. Okay, I think I'm just write it down. In case of cases, it's the loss. It's a loss of the specific three-dimension dimension shape of the protein molecule. So that's the denation. It's just basically the loss of the shape. So there are some factors or the conditions that affect the protein structure. Some conditions or factors that affect the denation of a protein. The condition that what causes rather, or the causes of the denation of the proteins. Condition affecting the protein structure. So there are some conditions that makes the protein not to function properly. Number one, we can talk of temperature. So you find that when the temperature is too high, the shape loses its nature. The protein actually stop to function. So these proteins that have got a specific temperature on which they can operate under. So the increase in temperature can cause more rapid molecules movement. Thus, because of that, they are able to break the hydrogen bonds. Okay, I don't know if I should let that one down. I think because of time, I'll just be explaining because of time. So I'm saying that temperature, the increase in temperature can cause more rapid molecular movement in the protein. So if you increase the temperature, there will be rapid movement in the protein. There will be rapid molecular movement in the protein, whereby it can break the hydrogen bonds that are in protein, and of which they can stop to function properly. So that's one. So the increase, so it's